5 boys and 5 girls are to be seated. How many ways can you seat them if there's no restrictions? So I'm going to put them into 10 chairs. Let's say they're watching a concert and I'm going to put them into 10 chairs. It doesn't matter. There's no restrictions. Okay? So how many options do I have for somebody to put into the first seat? I could put anybody. I could have 10 people, 10 choices. Then into the second position. How many options do I have on my second chair? 9. Then, do you see what's going to happen? What would be a faster way for me to write that in math? 10 factorial. Okay, and then do we even remember where our buttons are? See if you can find that button on your calculator. All right. They have to alternate, so I'm going to draw my 10 chairs again. So they have to alternate, boy, girl, boy, girl. They have to be beside each other like that. How many options do I have to put somebody in my first chair? I could put anybody. Anybody can sit down. How many options do I have on my second chair? What did you say? 5. Because I'm going to pretend it happened to be a girl on the first chair. So if it was a girl on the first chair, then I have only 5 choices because it now has to be a boy. So now if that, let's say, was a boy, now I'm back to girls. So how many options do I have now for girls? 4. Now I'm back to a boy, so I have 4 boys left. You see how it's going to continue? 3 girls, 3 boys. 2 girls, 2 boys, 1 and 1. Okay, you can multiply that all out. Or if you want something faster, I can show you how to do this faster. The boys would be 5 factorial. The girls would be 5 factorial. And I need to times it by 2 because I could have either started with boy or I could have started with girl. So that means that in my position 1 there was 2 options. That's why that was a 10. Okay, so do you see where the 5 factorials both come in? But then it gets doubled because of 2 choices. Okay, so you can either type that all in, or if you want it to be a little bit faster. Okay, I'm going to draw my 10 chairs again. Okay, this time Andrew and Zach have to sit beside each other. So what I'm going to do is I'm going to circle them up. Okay, so no matter what I do for moving them around, they're moving together. Okay, my first question would be, how many different units am I arranging now? Because they're treated like one unit together. So this is 1 unit, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm only allowed to move 9 things around because they're attached together. Does that make sense to you? Okay, because when I move them, I have to move them together. Then what could Andrew and Zach do beside each other? They could flip-flop around. Okay? getting me that number with your calculator buttons. Okay, so let's apply that to question D. Andrew, Zach, and Toby, the three of them are going to sit together. So these three people, when they move around together, kind of like having one position. So how many things am I going to be able to move around now? 8. Okay. I could move them around in 8 different positions. Then what could the three of them do within themselves? So it's saying to you, how many units are you moving around? And then within the units. So that's the strategy on these questions. How many units are you moving around? And then what's going on within each unit. Okay, they must sit in a boy-girl couple. Okay, so a boy-girl couple, well, that's a unit because they have to sit beside each other. Those two can't separate. Okay, so there's the units. So how many units am I moving around now? 5 units. Within this unit, they can move around. Within this unit, they can move around. Within this unit, and within this unit. Which is also the same as doing that. Does it let you do a 2 factorial to the 5th? Yeah, it does.
But a 2 factorial is just 2.
2, yep. I just was wondering if you just typed it in as a 2 factorial and then to the 5th, if it worked, and it does. I didn't know if it would let you. Okay, so the last question says, Andrew and Zach are not allowed to sit beside each other. So how many ways could we arrange with having them not sit beside each other? So does this make sense that if they sit beside each other, plus the scenarios where they don't sit beside, would equal all possible? Does this make sense? They're either that they're sitting beside each other or they're not sitting beside each other. Those are the 2 different scenarios. Okay, they're either doing that or that, but whatever that adds up to would be considered all the possible combinations. So I'm going to do this rearrange. So all possible minus the opposite event. Okay, does that make sense? They're either going to be sitting beside each other or not sitting beside each other. Okay, so this is what we call in math the complementary event. It's figuring out 1 minus the opposite event, or all minus the opposite event. Okay, all possible. That is which question? A, B, C, D, E? A. question A, which was 10 factorial. That's all that's possible. And then we did this question already, A, B, C, or D, or E. Which one was it? If they are beside each other. C. So can you take your answer from A, subtract your answer from C, and that's what we'd be left with. Okay, so if you ever hear me say complementary, that's what I'm referring to. All minus the opposite event.